Do you know that deep inside ordinary rocks lies a metal powerful enough to light entire cities or destroy them in seconds? This element is uranium, a heavy, naturally occurring substance whose true power comes from a tiny fraction of its atoms known as uranium-235. In its natural state, uranium is mostly made up of uranium-238, which cannot easily sustain a nuclear reaction. But uranium-235 is different. It is fissile. When struck by a neutron, its nucleus splits apart in a process called nuclear fission, releasing a tremendous amount of energy along with more neutrons that continue the reaction. This creates what scientists call a chain reaction. But here's the catch. Natural uranium contains less than 1% of this powerful uranium-235. To unlock its potential, scientists must increase its concentration through a process known as enrichment. First, uranium is converted into a gas called uranium hexafluoride. Then it is spun at extremely high speeds inside centrifuges. Because uranium-235 is slightly lighter than uranium-238, it can be gradually separated and concentrated through thousands of spinning stages. With just a small increase, around 3 to 5% uranium becomes suitable for nuclear power plants, where the chain reaction is carefully controlled to produce heat, steam, and electricity. At higher levels above 20%, it can be used for research and medical applications. But when enriched to around 90%, uranium becomes weapons grade, capable of triggering an uncontrollable chain reaction. In a nuclear weapon, this highly enriched uranium is brought together into what is called a supercritical mass enough material, packed tightly so that neutrons multiply rapidly without escaping. In a fraction of a second, an intense runaway chain reaction occurs. The energy released is not gradual, but explosive, producing a massive fireball, extreme heat hotter than the surface of the sun, and a powerful blast wave that travels outward at supersonic speed. The immediate impact includes total destruction of structures near the explosion, intense thermal radiation that can ignite fires kilometers away, and a shockwave capable of flattening entire city blocks. Beyond the blast, nuclear radiation spreads through the environment, causing acute radiation sickness, long-term cancers, and contamination of land and water. A rising mushroom cloud carries radioactive particles high into the atmosphere, which later fall back to the ground as radioactive fallout, affecting regions far beyond the initial explosion. The science itself is neutral. The same process that powers cities can also fuel weapons of immense destruction. That is why uranium enrichment remains one of the most closely monitored technologies in the world. From the quiet depths of the Earth to the forefront of global power and security, uranium stands as one of the most consequential elements known to humanity, holding both the promise of progress and the potential for catastrophe.